Okay, so hi everyone. As mentioned, today's session is on how we can predict and certainly optimize the performance using HyperMesh. Now, in today's session, unlike the other sessions, you will be wondering how is this session different from the other sessions and why HyperMesh, right? So as you must be aware that we have spoken a lot about advanced machine learning platform that Altair has to offer. You may have also heard of products like Knowledge Studio and RapidMiner, but today we are talking about something unique, something developed for the CA engineers so that they can quickly understand and start using machine learning in their day-to-day workflow, starting from very simple level. We are not trying to say that you will start using it on your vehicle level or full assembly level, but how you can start understanding machine learning and how to go about it, right? So let me just share. I hope you're able to see my screen. So when we say HyperMesh, I know it's a little ambiguous. Now I'm saying physicsAI. So physicsAI is is a tool set part of HyperMesh, or you can say a part of HyperWorks. So when you install HyperWorks and you have access to a certain amount of certain license entity, I think you can get in touch with the account manager to understand which license entity. You will have access to physicsAI, so you don't have to additionally buy it if you have it in your license bundle. Now, physicsAI is the ML platform where it gives the ability to the CA engineer to talk about machine learning, to use machine learning and get insights of it. Now, how is it different from the other platforms that we have, and you also must have used it, is Knowledge Studio and RapidMiner, is that it's not kind of a black box, but it's something which does not require a lot of, I would say, creation of a structured data. You can use your result files, your model files as is, if you have, and try to understand the how you can get predictions on the new set of data that you want to use machine learning for. In that case, in simple terms, suppose you have a lot of historical data, and all this historical data, you have to make some sense out of it and how to use and what to use. So answer is, can you use physicsAI, use all of that data from that you've collected over some months, years, and related to some one model or kind of models, and can you just get a new design, and without having to run your solver, you'll be able to predict the output responses, how much is a geometry variation affecting your results, and if it's really not a very linear static kind of a run, you can use it for non-linear simulation, CFD simulation, crash simulation. So that can be really useful where you don't want to really do a extensive HPC enabled simulation run, right? So in short, physicsAI is the platform, as I said, in HyperWorks, which will help the CA engineers to quickly adapt to use machine learning, and your CA results are fast. That means obviously any results are fast for CA users, but in terms of in context of a CAE where this simulation takes at least minutes, you'll be get answers in seconds to minutes for your result prediction. Now, what is the input requirement? Although the slides are only 2, but I still want to give a little bit of details that what is required for physicsAI to work. physicsAI needs, first of all, your input files, and also it needs a validation file, any design that you want to validate once you have created your machine learning model, right? Machine learning model in this case is geometric deep learning. So we are not saying that you can choose the machine learning model and really fine tune it to a great extent. There are few options available that we'll speak about it in the demo, but it's one model. You can research it in the literature about it. It's quite a well-known, available in the public domain, what is geometric deep learning, and that's how it's being leveraged in the background, letting the CA users use it, right? So when I talk about input files, it means historical data. Why I'm trying to emphasize on historical data is that you would have a lot of S3D files. Why I say S3D, you can also have anything which can be read in HyperView, for example, ODB files or any other result file that is compatible with HyperView can be read. Now, If at all you don't have that option of leveraging the historical data because you don't have it, you can perform a DOE. But the whole idea of talking about physics AI is you use your previous, I would say, S3D files or Hyperview compatible files, which are either performed manually because the C engineers are tweaking the designs themselves, trying to create various simulations, or they may have performed a DOE for some other context where they've parameterized the forces or the loading conditions or any sort of that criteria. So first of all, you can use all of that. You don't really need a structured data set. And then when you don't need a structured data set, you can use non-parametric CA files, right? In some cases, you may also require your the .fem or .rad files along with the result files, but those examples are very few and very use case specific. So in short, you can leverage your historical S3D files or Hyperview compatible files, which may or may not be parametric, right? That becomes your input. And what you need for validation, obviously, you can use your mesh files, which you will not be running a solver to validate the runs, or sometimes in many other scenarios, if you have created the machine learning model with certain settings, you can also use CAD files. So CAD files means it's just a step file or IGES file which is not being meshed. So you are really cutting short the whole development time if you're able to leverage the machine learning model and it's able to predict that, okay, now instead of 2 rows, maybe try to take 1 row, and can I get the stress concentration or the deformity patterns in the new design itself. So it's quite a handy tool for the CA engineers to really evolve their process and rapidly move ahead, right? Second point, I just want to reiterate why is not everyone is familiar with machine learning. So a little bit of idea, what is machine learning in context of physics AI, right? So when I say physics AI, what is required? As I said, you require input files, right? But what are these input files? A little bit of idea. You need different designs. Now, if you can still use one set of design with various boundary conditions, but to really make use of it, have you tried various combinations? In some cases, you have 2 rows, sometimes you have 1 row, sometimes you have added an extra feature on one side. Basically, it's a internal CFD HVAC use case, just to give an idea. And why we have taken this use case is because previously when we spoke about all the advanced machine learning models, we really never had a CFD use case. Right now, because we have a tool that can really help all these time consuming simulation runs with the machine learning, it's good to always use the CFD use case. This is internal CFD, and external CFD is still work in progress. That means the development team is working on it and would be available in the next few releases. So what I mean with input files is a little bit of information, having various types of geometry if you have. So what you really need is just a S3D file, right? Although I'm saying that you can just use this file as it is, but a lot of work will also be required by the engineer to understand if all the meshes are kind of same. Like, sometimes you may have done a coarse mesh and sometimes you have really fine mesh, like, really going very focused on the stress. Then the engineer may have to do some pick and choose, trying to say if the data points are not enough for fine mesh, maybe try to take a coarser mesh data set. So little bit of information would be required. I think it's best to discuss that on use case basis rather than if I talk in detail. But just to give an idea, you would require a bit of understanding your data set, visualization of your data set. If all your responses are giving the same kind of result, sometimes you have an outlier that you may have performed a simulation, but it has not converged and the results are really an outlier. Instead of 100 MPa, it's showing 0 MPa, right? So we have to really ignore that sort of data points from going into the physics AI training model, right? So that is what is a little bit of prepping that would be required once you start using it. So once you have your input files, what will happen is you will have options to give this input to physics AI in terms of a training data set or testing data set. By default, what we are saying is you can select that, okay, I want to take maybe, just I'm giving an example in today's demo, 7 files into training, and I would manually add 2 files into testing data set. But the user has the option, okay, I have a folder where I have 9 files or maybe 30 files. I want to give 70% to training and 30% to testing. So that option is there where user can ad hoc give a percentage and physicsAI will choose randomly, or you can dictate physicsAI to choose this for the training and another one for the testing, right? So once you have given these data set, after proper checking of these 10 or 30 data points, what is required is model training. So as I said, geometric deep learning model will be trained on these kind of data sets without having to give a lot of exposure to the user that, okay, what is this model, and you can read about it in the literature. You have 4 or 5 options. I'll speak about it in the demo to give an understanding of what are these. And once you have trained your model, right, you will be able to test it on this testing data set, depending, you're given 30% data set, 20% data set. And you will have, as of now in 2022.3 version, you have 2 matrices, which is mean average error and mean square error, to give you an idea how is the model. But in the newer, the next few versions, we're coming up with better metrics so that the machine learning user, which is just doing her regular or his or her regular CA work, can understand the predictions and say, is the model really good enough, or they have to retrain it or give more data points, right? So once you have tested your model, you can give a new design either on CAD or on Mesh, and you'll be able to get the predictions from the physicsAI. And this is how the prediction will look like. So you will have an ML model trying to predict not just the absolute values, right? If you are familiar with Knowledge Studio RapidMiner, you know that you're always predicting an absolute value, just elemental stress or a deformation or a pressure. In this case, we are trying to predict pressure, and it not just gives the values, but it also gives the contour. So it now the two assumption arises whether to match the value or the contour. It can be both. Sometimes you just want to look at the stress concentrations or some particular contour concentration, and sometimes you may be interested only in the value. So it's always will be a mix of both, right? So this is what I wanted to share about in terms of the concept of physicsAI. Let's look at the demo of it, how the input goes into physicsAI, how you create these data sets, how you train the model. Now, because it's a 30-minute TechBrew session, I will use very less values for training the model. So I will not use the exact values that I've used to get these results, but I will show these 2 files as well. So when you have a new FEM or a new CAD, how will the result look like, right? So I will just share HyperView now. I hope my screen is visible. So you're now what you're seeing is HyperMesh, the new interface. And once you have enabled, you have the right license file available with you, and you have enabled the physicsAI from the extension. Just to give an idea, in the newer releases, you'll be able to see physicsAI under ribbons if you don't see it under extension. So that's how you'll see physicsAI, right? So this is your regular workspace where you're trying to create your model build, creating your FEM or RAD files, or maybe using Design Explorer. Now you have physicsAI, right? And what you see on the screen is just of these options. Your 4 options are creating a project, creating a data set, then model training, and then model testing. And then what is left is predict, right? We'll not talk much about this option here. We'll talk about it in detail in the next couple of minutes, but what we're going to show is the project, data sets, model training, model testing. So without wasting a time, let me just show you what to create. So what you need to have is a folder, right? So just click. Why you need it? Because you need some relevant files to be created. Just click on these addition icon, right? It will pop up a window and you will be able to give a folder structure. So I would say I'll give it a name to this folder. Now I have to give a folder path. In this case, I will select this and I will say select the folder, right? You just have to click OK. Now, unlike your regular use of HyperView where you're used to seeing a model, this window disappears once you've selected a project, right? So it's not that it's not running in the background, it's still running. Next step is adding a data set. So what you have to do is you have to click on data set. That's why it was important to show the presentation showing the linkage between these steps, right? So now you have to create a database. So let me just take a folder structure from where I have these files, right? So what you have to do is first create a data set for training. So you click on training data set, you click on create data set. I will select the directory as I mentioned, and I will take input. In this case, I have 7 input points in my input data. I have 2 points in my test data and 2 points in my new design, which I'll be using for predict, right? So in this case, I will just take the input data. I'll select the folder. Now it has read all the files that it has to read, and are required, as I said, S3D files is the best demo for this application. We'll click on relative path. As usual, we'll click on this icon so that we are saying, okay, we are using all of these files. In case you also want to use the model files, then you may have to use edit this filter and say use a FEM or a RAD file. In this case, all 7 files are required. We'll click on OK, and it will prompt enter a data set name. So we'll say it's a training data set, right? You can give it any name you want. Okay. And it starts extracting features about the geometry, about how the model is configured, and that is important and is in the background. Now, we will not be able to tell you the exact details because it's proprietary, but this is what is the essence of trying to understand that your training data set has got these 7 files. We have extracted some relevant information that will help us in training the model, right? Now, going on, we'll add another database data set, but in this case, what we'll do is we'll try to add a testing data set, right? It's 2 data files. We'll select both of them. We'll select OK, and we'll call it as testing data set, right? So you've added 2 in the first step. Again, it will extract because you still have to test your data point, right? And we'll just click on OK. So you have 2 data sets, testing and training, 7 in training and 2 in testing. We'll just click on OK. As I said, the window disappears. Okay. Now we have to click on model training. This is the most important part after you have understood your 7 S3D files. As I said, you really have to understand what are these 7 data points. Are all 7 of them relevant? Do they have the same kind of a mesh? Not same means exactly the same, but if one is coarse and all courses all other are fine, it may not make sense to include the coarse mesh, right? Or vice versa. In this case, once you've done that, we'll try to add a model now. So we'll click on create model. Now the user is having a bit more options to understand. So first of all, you have to select the training data set. Select on which you want to train the data. I think it's important to understand and check both of them because it has to understand in some way what are you weighting in these 7 runs, right? In this case, because it is a different geometry itself, which is non-parameterized, so we would need these coordinates and the part ID. Now, in terms of solution, because if you're using crash or any other simulation, because it's CFD, you can select element stresses, displacement, or anything like that. In this case, we'll select pressure, right? And now these are the settings which the user has the option to edit, but not anything beyond this. And to understand more about these options, we will have a detailed help document from the Lex releases. In this release, we don't have anything more than just hovering on it and says, width is basically the size of your model, right? It is generally preferred to keep it as 30. Depth, if we are trying to predict the results on a FEM model, it is recommended to keep the depth of the model as 1. But if I suppose want to create another model, which will be I'm on the predictions on CAD, I would train my model on depth, right? But for this case, I will train it on FEM, so I'll say depth of 11. Epochs is the one which basically is the one that you can really control before trying to understand width and depth, is how many iterations you want the machine learning model to start performing, right? So in this case, because it's time consuming, maybe I should just take 50 and or maybe, yeah, I think for the demonstration, maybe just 50 runs. But what we have run parallelly, I'll show in some time, is these 2 runs where we have taken 500 epochs, right? So because the accuracy depends on it, and that's how it is important. Now, either you can train it on your machine, so it will leverage all the CPUs that you have automatically by default, or if you have access to a GPU, a CUDA network, you can register a training script and try to leverage that as well. So you have both the options. Obviously, you will require some bit of help, so I think we can discuss on case-by-case basis. In case it becomes a regular part of your framework, you can save this file into your folder, and when you start using it again and again, you can use from to import those settings, right? So in this case, because it's a demo, we are not saving the file, but you can click to settings file and these file will be saved, right? So just click on train, and what will happen is this model will get added to your model training log, right? And it will show as a status as pending. So a little bit of effort for the user to just keep clicking on refresh so that you understand, okay, model has started running now in the background, and it's no longer as pending. So we'll just wait for maybe a couple of seconds here. Yeah, it's running. So once it starts running, you can click on show log, and it will start telling you that how many epochs it has started running. So it's running just one epoch at a time, and as I keep clicking refresh, I'll be able to see. Now, the more number of epochs, the better the accuracy, but there's always a trade-off that would say how many epochs to give, right? Because we don't have the option still in physicsAI where we can say, okay, we have run on 300 epochs. Now we want to run on 500, and can we add just 200 more? No, as of now, if you have to retrain, you have to retrain from scratch. So I think they are actively working on that. So what I'll do is I'll show you the complete setup, but the results may not be accurate because we are running only on 50 epochs. But for accurate results, I have 2 more demos running. So I think that will make up for it. So I think just let's wait for it to run. So there's also capability where they're trying to give better indication of for CA users to not delve into what is MAE, which is mean average error and mean square error, rather giving them a metric saying this model is 90% good enough. You can go ahead and do the predictions. I think they're coming up with more simplified for the non-ML users kind of a scenario. It has run almost like 36 epochs. So obviously, if you have, it can handle very easily up to 1 million elements. So if you have more number of elements, then please do get in touch because we'll be able to help you whether this is the right use case that you want to attempt from physicsAI. Is it a very big assembly, or is it we prefer talking about as of now a system level or a subsystem level which has not many components but a few components to begin with. Physics, it doesn't really matter. Any results which can be read in HyperView are good enough for physicsAI to start working. And one more important point is that if you have 3D models in the next few versions, it will be able to extract the 2D mesh out of it and automatically run it. If you're using 2022.3, like some customers are, they would be provided with a script to extract the 2D mesh out of a 3D mesh, right? So in this case, we have run 50 epochs and we have a mean square error. Obviously, this value will be lower when I run with, say, 300 epochs or 500 epochs. But just to let you know that the model has trained, we just click on OK. Now, as you said, what you have to do is you have to click on refresh, and when its status is done, you have to click on set active model. This is important when you have you're training one for the CAD in the same session of HyperMesh, and you're saying the depth is 0. So in that case, you select the model you want to set as active, and that's how it is. So it says, okay, this becomes your active model. From this active model, anything you want to test and predict will be on that active model, right? So next step is model testing. In model testing, what you'll do is the 2 testing models, if you remember, from that we added in the data set will be tested for contours and the results and with the MAE. So I will say add a test model. I will say, okay, I'm checking this data set. Now it's scoring. Scoring means trying to predict the values for the unseen data set, right? From this model that you have trained. Obviously, because I've run only on 50 epochs, accuracy will not be very great. So I'm just showing the workflow. So it's very high MA number. We are getting close to 170 when we are running with the higher box. So in this case, just show results, just click on it. And what it'll do is it will try to create two windows, right? In one, you have your solver run that was original testing data, and the other one shows the contour of the new prediction and testing. Now, because I have run only with 50 epochs, we are not able to get the contours right, as you can see. So I have two models ready to explain that. So what I'll do is I'll just quickly show you how to predict on a new run, and then I will run through on the two examples, right? So what you have to do is to do prediction when you have trained with a good amount of epochs is, let me just take the file, 1 second. Right, I will just click here and say, you have to select in the first window, click on file, say I want to import a solver deck, which I am not running now with the solver, and I will select the fem file, which is your new input. Just click on import. And once you have this new file, what you have to do is just click on predict. It will leverage that model that you have just trained and predict the result for this particular iteration, right? So now this window will get updated with the results. By the way, 4:25 was supposed to be the poll time, so just 1 more minute, Swapnil, and then you can run the poll, right? So now, as you can see on the screen, the predictions are not very great because as I ran on the 50 epoch, but what is important is, are you able to get some understanding that this area is little bit causing a lot of issues for your run, right? Whether you're running with 50 or 100 epochs, it's not showing some absurd contour anywhere else. So that is what is meant by predict. But suppose you have used a good amount of epochs, this is how your result will look like. This is a new design, a fem file, and because I've trained the data on, let me see if I can show, if I have trained the data on 300 epochs and I have got a good amount of accuracy on this, the contours are really better than what you see with 50 epochs, right? With 50 epochs, just let me show you again, is really not trying to give you better information. It's quite missing some of the details, which is available now when you have added 500 epochs, right? Similarly for the CAD. Now, when you have a CAD model, as I mentioned, you have to train your data set with the depth of 0, right? So this model was trained in a different session with a depth of 0, and now without having to mesh your model, you have got a fairly bit good understanding of the epoch. So depth 0 really it's fast as model training, but it loses accuracy, but it is much more required when you're dealing with CAD. We can give you much more details when you have one-to-one discussions. So this is what is physics AI, very crisp, but I would really want to tell that you have to have some basics of what is model training, model testing, not too much of it, but little bit of understanding of machine learning. What are these input data sets you're trying to add in? Are these all ad hoc or part of various data sets that have passed the quality criteria, right? That all goes into physics AI and will really help you in predicting your results for many of these explicit time-consuming simulation runs. So I think in short, that is physics AI.